Hello Cloud Gurus, and welcome to the GCP Service Spotlight. In this series, we're going to put the spotlight on specific GCP services, walking through detailed technical demos to explore their features, benefits, and costs. I'm Broadus Palmer, and today we're going to talk about Google Cloud SQL. Now, if you're an organization, you're probably looking to maintain structured data and also have the ability to back up, protect, and restore it. Managing this yourself can be a huge headache, which is where the service can come in to help. Google Cloud SQL is a fully managed database service that can help you manage and administer MySQL, Postgres, and SQL Server databases in the cloud. In this episode, we're going to take a dive into using Cloud SQL, talk about the pros and cons, and in the end, I'll give you my final verdict. Using Cloud SQL can help you reduce costs by having it fully managed as well as automate storage capacity management so you can have the storage resources you need to support your application. You can access Cloud SQL from about any application such as App Engine, Compute Engine, and Google's Kubernetes engine. Also, you have reliable and easily configured backups and replication for your data, and not to mention that your data is automatically encrypted. Now, I know one of the most important things we worry about is cost. Cloud SQL addresses this by offering instances to fit any budget. Now, some of your costs will depend on the engine that you choose, whether it's SQL Server, MySQL, or Postgres. Instance pricing for MySQL engine is charged for every second that the instance is running. Now, with Cloud SQL, your pricing structure will also depend on CPU and memory, which can cost around 4 cents per virtual CPU. It can depend on storage, which can cost about 17 cents per gigabyte for SSD storage capacity, and networking and licensing, which can cost up to 19 cents per gigabyte for internet egress and up to 47 cents per core hour depending on the licensing. Now, one of the most important questions that we have when choosing the service is, how does it benefit me and my team? You get more secure connections to your instance as all traffic on internal Google Cloud networks is secured already. You will also have automated backups to easily replicate your data to a standby instance in another zone, which enables automatic failover from your primary instance, and easy import and export into Cloud SQL using cloud storage. Now that we learned a little bit about Cloud SQL, let's head to the demo and check it out. All right. I'm in my cloud playground environment, and I want to just show you guys how simple and easy it is to really set up a Cloud SQL instance. And we're going to be choosing a MySQL engine on this Cloud SQL instance. So what we're going to do is head down to storage, and we're going to click on SQL. We're just going to click on create instance, and we're going to choose MySQL here. And we're going to call this instance service instance. And we're going to set a root password of 12345. Just something very simple. Now, location, we can choose any region within the world. So we're going to stick to US Central 1 Iowa. And let's just say we're going to choose US Central 1A zone. All right. Now, for our database version, we have a choice that we're going to choose from MySQL 5.6 or 5.7. And 5.7 is default, so we're just going to keep it that way. And we're going to show configuration options here. So for connectivity, we have the option to add a private IP address for this instance so we could connect to it internally and not over the internet. And as you see by default, we have public IP already added to our instance. So we're just going to keep the default here. And we're going to go to machine type and storage. Now, our machine types are also known as tiers. Now, if you click on change, now this is the main image that you would use for your workload. Now, since we're doing a test environment, we want to make sure we save as much money as possible, right? So let's head to the DBF1 micro, and we're going to click on select here. Now, as you see for the DBF1 micro, we only have 614 megabytes of memory, but that's enough and definitely proficient for this test environment. All right, so if we head down to our storage here, we have the option to choose SSD or HDD. Now, SSD is solid state drives, and it actually is more lighter, faster, and uses more energy than hard disk drives. But hard disk drives are actually cheaper, and you can get more storage space. So we actually want a solid state drive disk that's lighter, more durable, and uses less energy. So we're going to stick with our storage type of SSD. Now we can enable automatic storage increases. So this is whenever we're near capacity for our storage will be incrementally and permanently increased. All right. Now for encryption, data is encrypted automatically. Now we can use a Google managed key for our encryption key solution, or we can use a customer managed key for an encryption key solution. We're going to stay with the default here. Now backups, recovery, and high availability. Now, automated backups and point-in-time recovery, as it says, helps you protect your data from loss at a minimal cost. Now, we can choose a window for our automated backups, and this should be used particularly for the window of the most downtime, right? So let's say if our downtime is we have the least amount of traffic from 1 a.m. to 5 a.m., that's when we want our automatic backups to complete. Now, we can enable point-in-time recovery and allows us to recover our data. However, if we do recover our data from a clone, we have to create a new instance to do so. All right. Now, availability, we could choose single zone or high availability. In this case, we want to choose high availability because Cloud SQL will create a failover instance in another zone. So if we have any type of disaster in, let's say, the US Central 1A zone, we will automatically fail over to the US Central 1B zone where our failover instance is, or US Central 1C. And here you can add some database flags. As you see, we have a lot of database flags we can add here for our Cloud SQL instance. So we're going to X out of this, and we're going to go to our maintenance window. Now the maintenance window, it should happen once every few months. So if we have a preferred window that our instance can undergo routine maintenance, let's say we're going to do a Sunday, and now we can choose 1 a.m. to 2 a.m. since we chose 1 a.m. to 5 a.m. for our automated backup window. We can choose the same here because that's where we have the most downtime for our instance. Now, order of update. Early timing is useful for test instances, allowing you to see the effects of an update before it reaches your production instance. Now, relative to the other instances in this project, we could choose any, later, or earlier. So we're just going to leave default at any. And labels, we can set labels for our instance as well, but we're just going to click on create here. Now it could take a few minutes for our instance to create, so I'll pause the video and I'll be right back once our instance has been created. All right, guys, our instance has been created. So it's a few things we can look at. We can connect to the instance over a public IP. We could connect using a Cloud Shell, a Compute Engine VM instance, and we could connect using other methods as well, which would be App Engine, Google's Kubernetes Engine, Cloud Function, and Cloud Run. Now we see our database version is MySQL 5.7. Auto storage increases enabled. Automated backups are enabled. Point-in-time recovery is enabled. We're located in the US Central 1A zone. Highly available. No database flag sets and no labels set as well. Now, as you see here, we have a few options: import, export, restart, stop, delete, clone, and failover. We can import and export data out of our Cloud SQL instance, and we can actually connect cloud storage to do so. So if we import data, we can import it from cloud storage and we can export it to a bucket in cloud storage as well. We can restart our instance, stop our instance, delete our instance. We can clone our instance here. So if I click on clone here, get this out the way, you see a clone is a separate independent copy of the master instance and can assist in point-in-time recovery. So let's hit cancel. And we can actually click on failover as well. So you can manually trigger a failover. And this will actually create some downtime for a few minutes. Your instance will not be available for several minutes while the failover is taking place. So if you're in a production environment, these are things you may want to consider, okay? So now we got a great look at how easy it is to really set up and configure a Cloud SQL instance. Here's what I like about using Google Cloud SQL. Cloud SQL offers high availability and great fault tolerance for your data, with data replications and 11 nines of availability and durability of cloud storage as well. The pricing was less than 5 cents per virtual CPU and less than 20 cents per gigabyte for storage capacity, and also being able to offload read requests with read replicas. Really, the only existing con I see at the moment is researching and improving on the need to connect with more existing data sources and marketing tools outside of Google Cloud itself. So, should you invest, evaluate, or revisit? My recommendation is to invest. Cloud SQL is a valuable service to use for easy access to your data. It's fully managed and secure, backed by a 24/7 SRE team. Scalability is super easy, and with Cloud SQL, you can get it set up with just a couple of clicks. So that's it. Keep being awesome cloud gurus, and I hope to see you in the next GCP Service Spotlight.